Dear learners, we are here for demonstrating the experiments of physics which are included in your secondary curriculum. Now, the details of the experiment, that is the objectives, the description of the apparatus, the procedure, the process of tabulation followed by calculation, drawing of graph wherever it is necessary, are all explained in your book meticulously. So, what we are going to do here, we are not going to repeat all that in details, but we will be talking about the salient features of the experiment and particularly the doable part, that is what you actually perform during the experiment, that would be demonstrated here. And in some cases, we may not be able to recreate the kind of apparatus which has been written in your book, but we will replicate that by some other arrangement which would give you the necessary hint as regards how to perform the actual experiment. So, this will be following throughout the series of experiments which we are going to demonstrate here. So, now we are going to demonstrate two experiments. The first one is verification of Ohm's law and the second one will be the study of bulbs connected in parallel. First, Ohm's law. The objective of this experiment is first to determine the least count of the ammeter and the voltmeter. This is your ammeter and this is your voltmeter. The second objective is to understand the complete circuit, that is the circuit diagram is given in your book and in accordance with that you have to prepare the circuit. Then you have to understand the sources of error so that you are careful while performing the experiment. And after you perform the experiment, where essentially we will be measuring the potential difference across this resistance. This is our test resistance, this wire. So, you have to measure the potential difference across that resistance and the current that is flowing through that resistance, and you have to draw a graph between the potential difference and current. And then you have to interpret the graph, which is very crucial, and that would help you in determining the value of the resistance. And after you have done all that, we will be doing a very small exercise. In fact, we would be changing the potential difference using different dry cells. Now, first we will be using one dry cell, then we will be using two dry cells in series, and then we will be using three dry cells in series. So, we will see how the potential differences across the terminals of the cell get added when they are connected in series. So, before we go for performing the experiment, let us state Ohm's law very clearly. Ohm's law states that temperature and other physical conditions remaining constant, the potential difference across a resistance is directly proportional to the current that is flowing through it. That means, potential difference divided by current is equal to a constant. So, before going into that relation, let us also understand the meaning of temperature and other physical conditions remaining constant. We can presume that wherever we are performing the experiment, the temperature is constant, particularly for the duration of performance of the experiment, but it would vary from summer to winter and other seasons. But on a particular day when you are performing the experiment, the temperature remains by and large constant. And what are the other physical conditions? Other physical conditions is this apparatus. This should be stable and stationary, there should not be much of a movement, and a very crucial physical factor is the pressure. Resistance changes due to pressure, and here you are using the knobs to tighten the wire and every other connection. So, the part of the wire which goes under this is called binding screw, which goes under the binding screw is under pressure. So, this part of the wire and the remaining part of the wire are under differential pressure. So, this is again a very crucial condition, and we have to remember that these things also should remain same throughout the experiment. As regards theory of the experiment, you did not worry too much. In fact, it is as good as stating the law, which I have already explained. V by I is equal to a constant, and this constant is the resistance of the wire which you are using for the test purpose. Now, let us perform the experiment. The first part of performance of the experiment is to create the circuit. Now, what are the components of the circuit? As I told at the very beginning, the main components are the ammeter, voltmeter and the test resistance in the form of a wire. And then the other crucial part is the power supply, and the power supply is a very simple thing, it is a dry cell. We have measured the EMF, electromotive force of each of these dry cell, and in open circuit, that is when it has not got connected with any other electrical accessory, the potential difference across the terminals of the battery is 1 volt. This is 1 volt, this is 1 volt, this is also 1 volt. But now we are using only one dry cell, and the other thing is this plug key. It is like the switch which you use at your home. That is, when you switch it off, current is not flowing in the circuit, but when you switch it on, current will be flowing through the circuit. See, this is the completion of the circuit, and you can see the pointer here. The pointer moves in the ammeter as well as in the voltmeter. The ammeter records the current, the voltmeter records the potential difference. But then you have also got to understand the other very crucial aspect of the circuit. This voltmeter has to be connected in parallel with the resistance, and connecting in parallel means the positive terminals are connected together, the negative terminals are connected together, and conventionally the red terminal is positive. So, this is connected. For the timing, I am just removing the key. This is connected with the positive of the battery. This is connected with the positive of the battery. That means, this is the negative terminal is connected with the positive of the ammeter. Then the negative of the ammeter is connected to the key which is now open. So, when the key gets closed, the negative terminal gets connected to the negative of the battery. So, that means this wire has this part at the higher potential and this part at the lower potential, and so by way of connecting it in this manner, it gets connected in parallel with the voltmeter. And since this is negative, this is positive, so this gets connected in series with the ammeter. So, it has to be connected in series with the ammeter and parallel with the voltmeter. And as regards sources of error, again you must have understood by now that the most crucial thing is to read the value of the current in the ammeter and value of potential difference in the voltmeter. So, if you look it carefully, you have a pointer here, the red pointer, and below the pointer there is a mirror. The image of the pointer can be seen in the mirror. So, you are getting effectively 2 points, the pointer itself and its image, and the third point will be your eye. So, you will have to put these 3 points in the same straight line, and the point of the pointer arc is from 0 to 3 ampere and 0 to 3 volt in the voltmeter. So, the point where this straight line meets the pointer arc will be the reading. So, you cannot take directly the reading. and this is how you avoid what is called the parallax error. That is, the pointer, its image and your eye should be on the same straight line. So, now we are in a position to begin the experiment, but before that we have to know the least count. This was a crucial objective. So, as I told that the maximum reading that can be taken by this ammeter is 3 ampere, and the minimum reading, see there are 20 places between 0 and 1 ampere. That means 10 places between 0 and 0.5 ampere, and 0.5 divided by 10 is 0.05. So, 0.05 ampere is the least count of the ammeter, and similarly there are 10 places between 0 volt and 0.5 volt. So, 0.05 volt is the least count of the voltmeter. So, now we are completely ready to begin the experiment, and for that I will request my colleague Ms. Vijay Lakshmi Pradhan to join me. The experiment begins by plugging the key. So, we have plugged the key, but still there is no movement here. This is because the circuit is open. What I have done, I have taken a connector, and this end, the conducting end, will be connected with the positive terminal of the battery by Ms. Pradhan. So, you can see current flowing, which is recorded in the ammeter, and the potential difference getting recorded in the voltmeter. Now, Ms. Pradhan would help me in doing the same experiment with 2 cells. That means, we are changing the potential difference. We are doing it in a crude manner, but you have to appreciate that we are doing it in a very simple manner. That is our objective. So, you see the current has now got changed, the potential difference has also now got changed. We will record that and we will do the analysis, and then we will be doing it with 3 cells in series. So, we are further changing the potential difference and trying to note the flow of current. So, now she had held the 3 cells in series and the potential difference has got changed, the current has got changed, and our objective was to study the variation of V with I. V is the potential difference, I is the current. We have taken 3 readings. During the first reading, the potential difference was 1.1 volt, the current reading was 0.5 ampere. In the second case, the potential difference was 2 volt, the current recorded was 0.95 ampere. In the third case, the potential difference recorded was 2.65 volt and the current recorded was 1.25 ampere. So, now we will analyze the result, and for that we have to draw a V versus I graph. So, we have taken a graph paper. Along the x axis we have drawn the current, and along the y axis we have taken the potential difference. Normally, along the x axis you take the independent variable, and along the y axis you take the dependent variable, and here we can presume that by changing the current the potential difference is changing. So, potential difference is along the y axis. Then we have to select the scale. So, see 5, this is a millimeter graph paper, and 5 centimeter is equal to 1 ampere, and similarly here 5 centimeter is equal to 1 volt. That means, each centimeter is equal to 1 by 5 ampere, 1 by 5 means 0.2 ampere. So, that means each millimeter is equal to 0.02 ampere. So, that is the smallest division along the x axis, and similarly the smallest division along the y axis is 0.02 volt. So, now we pick up the 3 readings. The first reading was current was 0.5 ampere and voltage was 1.1. So, you get the point here. In the second case, the voltage was 2 volt and current was 0.95, and in the third case, current was 1.25 and voltage was 2.65. So, that is how we get the 3 points. And once you join the points, you find them in a straight line which is passing through the origin, which shows that we have been able to establish V by I is equal to a constant which verifies Ohm's law. And then if you calculate the slope of the graph, then you get the value of resistance. You could have individually calculated V by I in 3 cases and you could have taken the average of the 3 values. But once you are drawing the graph, the better method would be to take the average from the graph itself. So, now we are going to determine the average from the graph, and for determining the average from the graph, we choose a point randomly on the graph. By choosing a point randomly on the graph means you choose a point from the straight line that you have obtained, and that point should be different from the experimental points. That is, by way of drawing the graph, you have neutralized whatever little bias was there, and so you are choosing the point from the graph itself. Now, we have chosen this point which corresponds to 0.8 ampere and 1.75 volt, and then the value of V by I, that is the average value of V by I, is equal to 1.75 volt divided by 0.8 ampere, which turns out to be 2.18 ohm. So, that is the value of resistance of the test wire. So, we have been able to verify Ohm's law and we have been able to determine the value of the resistance. And another part which you are also supposed to analyze, that whether the connection in series of the cells are giving you the ideal potential difference. Now, in the case of one cell, if you remember, the potential difference was 1.1 volt. In the case of 2, it was 2 volt. So, roughly you can say it is equal to 1 plus 1 volt. In the third case, we expected it to be 1 plus 1 plus 1 equal to 3 volt, but it worked out to 2.65 volt. That is because of the losses which are taking place after connecting the accessories. But roughly we can say that the potential difference are getting added when these are connected in series. So, while performing the experiment, you have to remember the sources of error which we have taken care of very carefully, that is the parallax error while noting the ammeter reading and the voltmeter reading. And then while making the connection, you have to make the binding screws very tight. The third thing is, whatever portions of the wire which are going below the binding screws should be clean enough so that there is no additional resistance. So, with this, I think we complete our discussion on Ohm's law. So, we ask you to take proper care of these sources of error and perform the experiment with a few more observations. We have taken here 3 observations, but you take 5, 8, 10 observations, more the number of observations, it would be better. And include all the points in the graph, so that if there is any variation, you are in a position to interpret the reason behind that. So, thereby we complete our discussion on the experiment of verification of Ohm's law. Thank you.
घर बैठे पाएं राष्ट्रीय मुक्त विद्यालय शिक्षा संस्थान यानी NIOS में एडमिशन। वो भी एकदम आसान तरीके से, जिससे शिक्षार्थियों को होगी समय और धन दोनों की बचत। NIOS से शिक्षा कभी भी कहीं भी। शिक्षार्थियों, क्या आप जानते हैं NIOS में एडमिशन लेने का सरल और सुगम तरीका, जिससे शिक्षार्थियों को ऑनलाइन प्रवेश लेने में सहूलियत मिलती है। NIOS में प्रवेश की प्रक्रिया पूर्णतया ऑनलाइन है। शिक्षार्थी घर बैठे इंटरनेट द्वारा प्रवेश के लिए सबसे पहले NIOS की वेबसाइट www.nios.ac.in पर लॉगिन करें। अपना ईमेल आईडी और पासवर्ड डालकर अपना पंजीकरण करें। पंजीकरण के बाद लॉगिन करने पर ऑनलाइन प्रवेश हेतु आवेदन पत्र खुलेगा। आवेदन पत्र को निर्देशानुसार भरें और प्रिंट आउट लें। इस प्रिंट आउट पर अपनी फोटो संलग्न करें। ऑनलाइन प्रवेश के लिए शुल्क हेतु भुगतान के तरीके हैं: क्रेडिट कार्ड के द्वारा, डेबिट कार्ड के द्वारा, राष्ट्रीयकृत बैंक के ड्राफ्ट के माध्यम से, जो कि सचिव NIOS नई दिल्ली या नोएडा के पक्ष में देय हो। भरे हुए आवेदन पत्र के साथ साथ डिमांड ड्राफ्ट और संलग्न किए जाने वाले दस्तावेज हैं: जन्म रजिस्ट्रार के जिला कार्यालय से जारी जन्म प्रमाण पत्र की सत्यापित प्रति, जिसमें जन्म तिथि अंकित हो, पिछले विद्यालय से प्राप्त विद्यालय छोड़ने का प्रमाण पत्र, जिसमें आवेदक की जन्म तिथि लिखी हो। प्रवेश फॉर्म का प्रिंट आउट NIOS के संबद्ध क्षेत्रीय केंद्रों पर 10 दिनों में पहुंच जाना चाहिए, अन्यथा उचित दस्तावेज न लगे होने पर आवेदन फॉर्म रद्द किया जा सकता है। प्रवेश प्रक्रिया की पुष्टि होने के बाद शिक्षार्थियों को परिचय पत्र व अध्ययन सामग्री डाक द्वारा तुरंत पहुंचाई जाती है। ऑनलाइन प्रवेश एक बहुत ही सुगम और सुविधाजनक प्रवेश प्रणाली है। ऑनलाइन ऑन टाइम फॉर सेफ एंड सिक्योर एडमिशन।
हिंदुस्तान के हर कोने में नौजवानों के पास प्रतिभा है, उन्हें अवसर चाहिए।
NIOS देता रहा है युवाओं को अवसर आगे बढ़ने का। NIOS से पढ़ने वाले इन युवाओं ने किया है संस्थान को गौरवान्वित। दिव्यांगों ने बन के दिखाया है सबल और आत्मनिर्भर। NIOS के साथ आप भी जुड़िए NIOS के संग।
So this is the second in the series of our electrical experiment, and this experiment is about household connections. So we are showing a very simple kind of connection with 2 bulbs and 2 switches, and that is again prescribed in your book, but we have made a deviation. In your book, though it is mentioned household connection, the power supply used there is a DC source, that is a battery with a fuse. So we thought that it would be better to use an AC source, which is the normal practice for all household supply, and we have not used any kind of a fuse because the role of the fuse is being almost done by the switches, because in the main source from where the power comes, we have the prescribed fuses. So you just have to visualize the same circuit with an AC power supply. The objective of this experiment is to know the components of the circuit. The second objective is to do the connection. The third objective is to understand the difference between series and parallel connection. And the fourth objective is to understand that why we go for only parallel connection in case of household electricity, or for that matter any kind of electric connection. Say during Deepavali you have so many bulbs, series of bulbs connected. Do not confuse the word series with series connection. During Eid-ul-Juha, Eid-ul-Fitr, or say during Xmas, you see lot of lighting arrangement with very small bulbs. So, in all those cases connection is done in parallel, and why so, that would be demonstrated through this very simple experiment. The first is to understand the components of the circuit. As regards components, we have 2 bulbs and 2 switches, an arrangement for connecting them with wires. Now, had it been a DC source, we would have talked about positive and negative. Here we will be talking about phase and neutral. So, this is the phase part and this is the neutral part. From the phase part, we have connected the 2 switches, and from the neutral part, we have connected the other end of the 2 bulbs. So, this is connected in parallel, and had it been connected in series, then it would have been neutral phase, but this is neutral, phase, and that is what we have done in the parallel connection. And then I will just demonstrate what happens when we switch on the circuit. Now, the circuit can be switched on in 3 different ways. Number 1 with this switch, number 2 with this switch, and number 3 with both the switches together. So, I will do all the 3 operations. First, this switch, you see this bulb is glowing. Then I switch off, I use the second switch, this bulb is glowing, and then I switch on both the bulbs are glowing. So, you can understand that with this kind of parallel connection, individually the switches can operate the bulbs, collectively also they can operate the bulbs. So, these 3 operations, that is using this switch individually, using this switch individually, and using the 2 switches collectively, has been recorded in the table which you can see on the screen. And this is which is happening in every household circuit. In your household circuit, there are several appliances, bulbs, fan, motor, AC, so on and so forth. So, they can function individually, you can very well understand, they can function collectively. If you have, say, 10 accessories, only one of them can be made to function, 2 of them can be made to function, all 10 of them can be made to function, and that is why the connection should be made in parallel. Had it been done in series, then if someone malfunctions, then the entire circuit goes off. So, in order to understand this basics of household circuit, we have performed this experiment, and the power, which is voltage into current, that gets distributed, and in each case whatever is the power consumed gets added. Like now the power being consumed is the power consumed by this bulb plus the power consumed by this bulb. If there are number of accessories, the total power consumed would be the sum of individual power consumed. Thank you.
हिंदुस्तान के हर कोने में नौजवानों के पास प्रतिभा है, उन्हें अवसर चाहिए।
NIOS देता रहा है युवाओं को अवसर आगे बढ़ने का। NIOS से पढ़ने वाले इन युवाओं ने किया है संस्थान को गौरवान्वित। दिव्यांगों ने बन के दिखाया है सबल और आत्मनिर्भर। NIOS के साथ आप भी जुड़िए NIOS के संग।